Hello, everyone out there. This lesson is intended to augment or provide some additional examples that were not shown from section 2.1 of the homework. So in this part, we are looking in section 2.1 and looking at some additional examples. So here in number 6 and number 7, we're asked to take these kind of verbal expressions with some math involved and write these out as mathematical expressions in a more sophisticated way. So, for example, we're told to add these two things together. So, if that's going to be the case, I know I'm going to add two things together, so I'm going to create a space to put those things. Now, in the case of addition, it doesn't really matter what you put where. So, if it tells me to add 6x plus 3 to 7x minus 8, I can write this as like 6x plus 3 here and 7x minus 8 here, and nothing's really going to change. Usually because if we're adding this to that, I would probably just write it as 7x minus 8. And then here I'd put 6x plus 3. And then, once we have this written out, we can talk about, all right, 7x plus 6x, that's going to combine to give us 13x. And then negative 8 plus 3, that's going to combine to give us negative 5. If you need a calculator to use that, you certainly can. Where this technique of creating some space to do some work is going to come in handy is going to be in question 7. And in this one, we're told to subtract 9x minus 9 from 6x minus 1. If we're told to subtract from something, well, this is a little different. So let's say I take subtract 3 from 10. If I say to subtract 3 from 10, that's going to be like taking 10 minus 3, which means that if I have it phrased this way, that however the information is put into the problem, I'm going to turn it around to actually do the math, because if I subtract 3 from 10, I should get an answer of 7. But the way I do that is to turn these two things around here. So if I'm given this statement here, I know there's going to be subtraction. So I'm going to create space to put the things in there in order to carry out the operation. So if I'm subtracting 9x plus 9 from 6x minus 1, what's going to happen is the following. Since I'm subtracting this from 6x minus 1, like from this, I'm going to subtract this. Okay? So I'm going to write here 9x plus 9. Because I'm subtracting that quantity, it's kind of like having a minus sign and a parenthesis outside, which means I'm going to need to kind of distribute the negative through here. Okay? So there's a few things going on with us. So first, we have to be cognizant about turning those around to make sure those are in the opposite order. And then we have to distribute the negative through. So below we'll get 6x minus 1. And then negative 1 times 9x will be negative 9x. And then negative 1 times 9 will be minus 9. At this point, we no longer have parentheses. We can carry it out and combine like terms like we've been taught in class. And from here, we can take 6x minus 9x, and that's going to give us negative 3x. Negative 1 minus 9, that's going to go and give us minus 10. So the final answer to this in question number 7 is going to be 3x minus 10. We'll go ahead and take a look at question 9 now, just to kind of go through an additional example of this here. So we have in question 9 5k minus the quantity of 3k minus 5. So if I have a negative next to a parenthesis, what's implied here, and we talked about what's implied in class, is 1 and then times. So I'm multiplying everything here by a negative 1. Not changing the 3k, not changing the negative 5, but changing their sign rather. So this is going to be 5k minus 3k plus 5. From that point, we would take 5k minus 3k, or 5 minus 3. That's going to give me 2k, and then plus 5 comes down. And that helps out with question 9 here. We're going to go ahead now, and we're going to go to the next page, and we're going to take a look at a question like question 10. And let's see how a question like this is done. In fact, if you just want to kind of skip question 10 altogether, I would be perfectly okay with that. because the numbers here aren't exactly really friendly. I mean, we could talk about getting rid of the fractions possibly, but I'm not going to tackle that one here. If you want to see that, I'd be glad to show that to you in class. All right, so let's take a look at number 11 now. Let's see what we can make sense of with that. It says 4/7 of a number increased by 15. So what we're going to do now is we're going to just tackle these things one at a time here. We want to take this verbal expression and then write it as an algebraic expression. So one thing you need to know is that of is going to be a symbol for multiplication. Increase by is going to be plus. So we have that. We have 4/7. So what's 4/7? That's going to be 4/7 of a number. Well, usually that number we're going to refer to as x. Increase by 15. So we have 4/7 of a number increased by 15. So this is going to be 4/7 of a number increased by 15. And that's how that gets written from a verbal expression into an algebraic expression. So now we're going to try this one out here, and let's check to see what we get here. It says the sum of. So we know we're going to be adding some things. So if it's going to be the sum of, I'm going to create a space to put two things to for that. The sum of 2 times a number and 7. So the first part about this is 2 times a number. Okay, that's the first part. That goes here. And -7. So I'm going to put that as -7 here. And now it says further it's going to be added to 9 times the number. So I'm going to add this to 9 times the number again, the number being x. So this is going to be 9x here. So that's another way we can construct an algebraic expression out of that. And when we want to clean this up a little bit, we have plus and minus. So now that we have plus and minus, this is going to become a minus sign. And then we're going to be left with 2x minus 7 plus 9x. So 2x plus 9x will become 11x. And then this minus 7 is just going to remain minus 7. So this is going to be 11x minus 7. Finally, let's go to question 13 now. Let's see what sense we can make out of that. It says, recall that the perimeter of a figure is the total distance around the figure. Given the rectangle to the right, express the perimeter as an algebraic expression containing the variable x. So if a perimeter is a total distance around, what that means is, what we're going to do is we're just going to go ahead and add the 4 sides together. I'm going to make a place to put all of that. So I'll just start with this as being the first side. That's going to give me 3x minus 3. This side is going to be 3x. Third side is going to be 3x minus 3. And the last side is going to be 3x. And if I add that up, that's going to give me the perimeter. Well, I look for my like terms now. 3x plus 3x plus 3x plus 3x. That's going to combine to give us 12x. And then -3 and -3, that's going to combine to give us -6. And that's going to be the final answer to that last question. And that summarizes the questions that I'm going to choose to go over for section 2.1.